Welcome to Spring LIB.
We're told that a cone with height little h is inscribed in a larger cone with height big H, so that its vertex is at the center of the base of the larger cone. We're asked to show that the inner cone has a maximum volume when little h is 1/3 of big H. So let's draw a side view of the cones. First, I'll define some variables. I'll let big R be radius of the larger cone, and big H is the height of larger cone. We're already told this. While little r is the radius of the little cone, and little h is the height of the little cone. Now I'll draw the larger cone with the smaller cone inside it.
Yeah, it's Bushy and fucking Bose in Tokyo. Yeah, it's really Alechi, Sefi, Van, Hellon, JP Clark, Elmathan John. Elmathan? Yeah. Dude, yeah. That's Elmo's. It's like Elton John.
First we have a right triangle here. Now, looking at this figure, we actually see similar triangles. So we have the larger height h over the larger radius r. This is the same as the smaller height little h over the smaller radius little r. I'm sorry, not quite. It's the difference between heights, big H minus little h, over little r. Because we have this larger triangle here, and the smaller triangle inside of it. Okay, so we'll solve for little h, and we get that little h equals big H over r times big R minus little r. Now let's substitute this result into the equation for volume. So the volume of the smaller cone, this is 1/3 pi r squared little h. And so we get 1/3 pi r squared times big H over big R times big R minus little r. And so we can express the volume as a function of r in this way. So volume of little r, this is 1/3 pi r squared h minus pi r squared h little r over 3 big R. So this is the same as pi r cubed big H over 3 big R. Now I'll differentiate with respect to r. V prime of r is 2 pi r big H over 3 minus pi r squared big H over big R. We want to find when this is equal to 0. So I can factor this as pi RH over 3 big R. And I have left over, this is 2 big R minus 3 little r equals 0. And so it follows that either r equals 0 or r is equal to 2 big R over 3. Now the radius of the smaller cone can't be 0, so we're really only considering our second critical value. Now notice that the factor 2r minus 3 little r is in fact greater than 0 if and only if little r is less than 2 big R over 3 and 2r minus 3 little r is less than 0 if and only if little r is greater than 2r over 3. Therefore, by the first derivative test, it follows that our volume V has a maximum at r equals 2 big R over 3. And so the height of the smaller cone at this level for r, little h, looking at our previous equation, this is big H over big R times r minus little r, which is 2 big R over 3. You can factor out the big R. We get h times 1 minus 2/3, which is big H over 3.